welcome to this video on Swift structures, also known as Struct. Swift structure are basically a user-defined data type that can encapsulate properties and methods into one single entity. And it is used at various places, especially when we make API calls. We use structures to model our data when we receive a JSON response. We can model it into a local data that we can use to display onto the UI. And there are various other applications. We'll start with basic syntax to get a basic example, and then we'll jump into some use cases, and then finally the real world examples. We'll also take a look at the mutating keyword in Swift structure. So let's get started. So here we'll start with the first thing, that is basic syntax. Now to declare a structure, we use the keyword struct and we give the structure name. Inside here we can give properties and methods. So to give one property variable, property name, and some data type. To give a method, we have to use the func keyword, then the function name, parentheses, the return type, and we can return there's some logic we can write in the method, and that is it. Let's fix this. Struct is the keyword. Now let's take a look at an example. I will mark it as example. So let's create a struct person. A person has a name of type string, age of type integer, and we can create a function intro, inside which we can write hi. Now this is a structure named person, which has two properties, name and age, and a method with no logic but just printing statement. Let's run it. First I will create an object person, and I will create this let constant and assign the object. To create the object, I can write person and initialize it with the parenthesis. To initialize, we have to give values to this property, name and age. So I can give Alice, age 30. Now I can use this person and a dot operator to access the properties, name and age, and the method intro. Let's access intro and let's run it. Yeah, I have to comment this because it is just a syntax, not really a code. Let's run it now. It says, hi, I'm Alice, my age is 30. And that is how a simple structure looks like. Now let's take a look at a concept called mutating keyword. Now let's say I'll create one example, struct counter. I have a count variable in it with a value already given, that is 0, and there is a function increment which will increment it by 1. I will create its object counter. I don't have to initialize the property counter count, this one, because it is already having a value, a predefined value, and I will get a variable for this counter and I will call increment. Let's try running it. Before that, I will comment this. It will throw some sort of error saying that It's not mutable. Now what this arrow says is the left side of the mutating operator is not mutable. Self is immutable. What it exactly mean is it also says mark the method mutating to make the self mutable. Right now, the structure is not mutable in the sense the properties inside it cannot be changed. Now, if there is a method inside the structure which is making a change in it, then you have to mark those functions with the keyword mutating. And now we can run it. Now the error says that the let, now this is a let, I have to mark it as variable so that I can allow the change. Now once I'm done, let's run it. And it's not throwing any error. Let's print the count. So I will say counter dot count. Let's run it now. And we get 1. Now let's take a look at some of the characteristics of structure. The very first one is its value type. Well, what it means is when we copy a structure object into another one, it copies it by value. Let's take a look at an example. I'll create a property here, data of type integer. I will create its object and we'll give it a value, let's say 30. I will call it first object. And now I'm going to create second object variable and give it a value that is first object. Now here what I'm doing is this first object I've given it as a value to second object, and so what I'm doing is I'm creating a copy here, but this copy is independent. If I make any change into this object, it will not affect this object. That is first. What do I mean by that is if I do second object dot data and I change it to some random value, let's print both the objects data. So I'll print first object dot data, second object dot data. I will comment this print here. Let's run it now. So the first object is still having value 30, and when we change the data of the second object and check the value, it is changed. So what exactly it does is it does the copy by value. It means the second object is independent and it will just copy the values of the properties of first object. And that is what it means when we say copying, then it will copy the instance properties state the values, and hence we call it value type. I'll write it here. Now if you take a look at this structure person, it has two properties and a method. It also has a initializer. If I will type it init here, you will see a suggestion here. It says a code snippet, and I will press enter. We'll see it gives a method name init. Now this is more of a constructor, or exactly a constructor for structure. This is hidden in the structure and it comes with every time you declare a structure. There is a default initializer that is also known as member wise initializer. Now when we create an object like this, we are actually running init, or we are constructing this object here. I will delete this And you can make a custom initializer as well, meaning that you can make some change here. Say every time you get a name, or you get an age, you can just add 1 to it, and now it became a custom initializer. If you don't want to give any custom logic while initializing the object, you can just delete it, and it is hidden by default there. And that is what initializer means. Also, we have 4 types of initializer that we will take a look at in a separate initialization video, where we will see all the 4, that is the designated, convenience, failable, and required initializer. We will see how all of them works in integration with each other and their real world application as well. Let's take a look at one example where we will give a custom init. So I'll create a structure circle, and we have a variable radius of type double. We have an init. Now I'm going to expect diameter, and what I'm going to do when I'm going to initialize the radius, I'm just gonna give diameter divided by 2. So every time when I will initiate or construct the object of the structure circle, I will have to just give here diameter, and it will initialize the radius by dividing it by 2, and that is all. That is a custom initializer for us. Now you must have noticed there is a self keyword here. What it is doing, let's go to this example and unhide that init. Here we have this method init, and we are taking 2 parameters, name and age, which is these 2, and we are assigning these 2 to these 2 variables. Now self is denoting this block of code, that is the person, and using self we can access this name and this age, to which we will give name, which is here, and age, which is here. So self is just to distinguish between the parameter names and the property name. Let's print this radius. So I will say variable circle radius. Let's print it. I will comment the previous print functions here. We don't have any more prints above. Let's run it, and it gives me 2.0, which is half of 4. Now let's take a look at the third point, that is protocols. Structure can conform to protocols and can also have extension. Now right now we will just take a look at what it really means, that is conforming to a protocol and having an extension, in a separate video where we will start with protocol introduction, and we'll go deep into the concept of protocols and extension. There we'll get into the real world examples as well, and much more deeper into what protocols and extensions are actually. Here I will just give you a quick walkthrough on what protocol is and how it works with structures. So let's take a look at the example. I'll mention here. I will also mention at the top. So what I'm going to do is create a structure product, and I'm going to declare 2 properties here, name and I will have function something like this. I will create product, and I will give name course on Swift, and the price is 1. Let's create product, Let's get the object and we'll call product.describe. Let's run this. Before that, I will comment this print. Let's print it as well and run it now. So it gives course on Swift cost $1.0. Now, what protocol means is that in general, protocol means set of rule that you must follow. A protocol that we follow in healthcare industry, every doctor follows a protocol whenever there is a patient in ICU or in emergency case. So protocol really means a set of rules. So for example, I want a rule for this structure named product that I want to have this describe method, and it should be a rule. Suppose if I delete it, it should give some sort of error at compile time right here. So what I do is I will leave that method here first. I will create a protocol here and some protocol name I will have to give, and inside that I will mention this method's name. Also, I will have to mention a func keyword and a parenthesis and what it should return, which is string. And that's it. You have created a protocol. Now I want this product to conform to this protocol. What it means is that the product must follow this protocol. So I will copy the protocol name, and to make the structure conform, I will have to use colon and the protocol name. And that's it. Right now, product conforms to the protocol name. What it means is that it is mandatory for product structure to give a definition for this function. Right now it has a definition. Right now it's not a problem, but if I delete it from here, it will give some sort of error here. Let's try running it. I will comment this part and let's try running it. Now it says type product does not conform to protocol name. And also it says the protocol requires function describe with the type this. Add a stub for conformance and more. So what does it mean is that I have to give a definition here, and it's mandatory for product to follow this protocol. And that's it. That is what protocol really means. Let's move to the second thing, that is extension. So we just saw what protocol means and what conformance really means here. Let's take a look at extension. Now suppose I will first mention this here as a comment. I will uncomment this and let's take a look at extension. Now suppose we have a feature coming in, a new feature, and I want to write a code for that. And I have this structure here, but I don't want to touch this structure code, but I still want to declare a method inside here. What I will do, I will create an extension for it. So I will do extension. I will give this keyword and the name of the struct, that is product. And inside here, I can mention this function new feature, and I can write some logic here for that. Let's say it prints new feature. That's it. I will use this object we created and access that new feature method, just like that. And I will run it. Before that, I will comment this print. Let's run it now. And it says new feature. That is what extension is. It just used to extend the functionality of structure. And again, we will have a separate video on protocols and extension in which we will dive deeper into this topic. Let's move to some real world use cases of Struct. Now the very first is we can use it for modeling a real world entity. That could be anything. That could be a car, person, work, etc. That could be anything. That is the first. And we can just like we created a product, we can create a person with name and age. I think we have created it here like this, and just like that. That is one use case. We can represent some geometric shapes as well, like rectangle, circle, and we can define the state of the UI as well. And one more important one is when we use or make API calls, network calls, we receive a JSON data. We can decode that data. At that time, we need a structure to create a local model. We need a structure to convert this JSON data into the local model. Let's take a look at example of that. I will mention it here. That is JSON parsing. And so what I will do is I will create a JSON data. I will actually bring it here. So we have this JSON data. What I'm going to do is I'm going to create a JSON string. So we have this in the form of a string at the moment. I'm not going to be writing the code to make a real API call at the moment. And we are just considering we have made the API call and we have the JSON data with us. But to use it and to display this JSON data into the UI, we need to convert it first into the local model. And that's where we use a structure. So what I will do is I will take this JSON string and use a method called data, and I will give it a format .utf8. Now what this data method does is that this method converts the string into the data object, which basically means that it's a Swift representation of binary data, and this is the format that we use for encoding or transforming the string into the binary data. And I will take it into let constant JSON data. Now this is the data format or data. The type of this let constant is data. We can use it to convert it into a local model. For that we will be needing a local model. That's where we will be using struct, and also we will take a look at enum as well. So here I will say if let there is JSON data, and then it will go inside the if block, and here I will do the decoding. So what I will do is create a JSON decoder and use decode, and here I will say from, and I will mention the JSON data. Now there's one more thing that I have to mention here, that is a structure for reference, which is going to be used when it is decoding the JSON data into the local model. So for that I will have to create here that structure. I will complete this line first, let response. So the decoded data will be the decoded response, and we can use it further. I will create the structure for that. So we'll start with the API response. We are calling this whole thing API response, in which we will have a status, message, and data. So I will create a struct for that, and inside that I will create status of type status. Now here we know that the set of values that is possible for state is going to be the success or failure. So instead of creating a string type here, I would rather create a enum, and I will name it status. So let's create that enum status, and I will give here the case success and failure. And that's it. That's how we use enum and structure together when we are converting or decoding the data. I will mention message and data as well. I will copy message, create a variable here, and the type will be this users fetch successfully is type string. So I'll give it a string here. And we have the data. I will create a variable for that. And if you see, it's the array of some particular data. So what I will do is I will create array of some type here. Now let's decide a type for these values. We can call them, it has ID, names, and email. So it seems like a user data. So I will create a structure for that first. I will name it user, and I will have ID, name, and email. Now if you take a look at the values, ID has 1, and which basically means it is of type integer. Name has Alice Bob, seems like it's a string, and email seems like a string, so I will give it a string. And this user becomes the type here. So now we can say data, which is this, is an array of type user. And that's it. We have our structure ready. We have a root structure that is API response, which has status, message, and data. And status is of type enum, status has success and failure. And we have the data, which is an array of user. So we have created a status and user here. I will bring this down here. Now the only thing is left is this structure in and enum has to conform to a protocol called codable, because for this type to be able to help here, if I mention it API, I will copy the name and mention it here, that API response dot self. I'll give it a comma. Now I will make all of them to conform to a codable protocol and do the same thing with structure and this structure. And that's it. Now we have this local model ready to help in the conversion of the JSON data into a decoded response. Now we can use this decoded response constant to access all the values, that is status. So when it comes to decoded response, it will give me this, and I will try to print it. Let's comment the previous print comment, which is this, and let's try running it. Okay, so this error says that the playground execution terminated, an error was thrown and was not caught. Now, when we do this decoding, it might fail sometime, so we have to put a try keyword here. Also, when it comes to the status, I can print its raw value, And for it to have a raw value, we have to mention the raw value type here. And let's run it now. And it gives us success. We can also access other values. We have just access the status. We can access message and data as well. Let's print the message. Now it says this property is defined on API response. It may not be available in this context, but let's try running it first. And it says user fetched successfully. So sometimes the Xcode does this kind of tricks on us, but you should just try running this first and read the error in the console here. Now let's try accessing the data. Now what we will do is we're going to response.data and I will take it into users let constant and I can print it as it is, or I can iterate over each value and print ID, name and email. Let's first print this value as it is. Let's run it and it gives me not so readable format. So I would write a for loop user in users print id user.id and we have email. So user.email. Let's run this and we get ID1 Alice and Alice email and the second entry. And this is how we use a structure to model while doing the JSON parsing. First, what we did is we used the data method and gave it a format so that it can convert the JSON string format into a local binary format that Swift can understand. And to that we call data type. The type is data. I can mention it here as well. This becomes the type. I will remove it from for now, let it infer automatically, and then that JSON data is ready for decoding it from JSON data using the local model that we created and this is our local model, and every type must conform to the protocol codable, and this is actually a type alias for encodable and decodable, and together we just make it conform to codable so that whenever we are doing decoding or encoding, this type can be used for both the work. And that is it. Now let's take a look at some differences between enums and structure. The very first one is the purpose. Structures are used for data modeling. Enums are more of a specifically used for finite set of related cases, related values, user defined. And when it comes to properties, in structure we have stored properties like variable names, and we have given a type or let's say ID, things like that. And when it comes to enums, we have these associated tied strings with each case. Uh, Here we can give some raw value, custom raw value. And when it comes to inheritance, both of them does not um, do any inheritance, but structures are value type model, and when it comes to enums, it is more suited for type safe case handling. So these are few differences which I will mention here. And just for the notes, when it comes to purpose, properties, and inheritance, these are the few differences between the structure and enum, and that is all. I hope you find this video informative, and let's connect in the next.